Next problem. The length in time in hours it takes an over 40 group of people to play one soccer match is normally distributed with a mean of 2 hours and a standard deviation of 0.5 hours. A sample size of n equals 50 is drawn randomly from the population. Find the probability that the sample mean is between 1.8 and 2.3 hours. So first, let's go ahead and write down what we know. Our mean is 2 hours, standard deviation is 0.5 hours, sample size is 50. So we know that we can write our notation like this. We know that we are looking for the probability that our sample mean is between 1.8 and 2.3. So to do this, we are going to simply plug it into our calculator. We are going to put normal CDF 1.8, 2.3, 2, 0.5 divided by square root of 50. And we will get 9.9977. So a 99.77% probability that the sample mean is between 1.8 hours and 2.3 hours. Next problem, number 3. In a recent study reported October 29, 2012 on the Flurry blog, the mean age of tablet users is 34 years. Suppose the standard deviation is 15 years. Take a sample size n equals 100. So let's write down our information first. Okay, so there's our information. What are the mean and standard deviation for the sample mean ages of tablet users? So if you recall, the mean of the population and the mean of the sample will be the same. So 34 years is the mean. Now, the standard deviation and the sample standard deviation are slightly different. So the standard deviation of the sample is standard deviation divided by the square root of the number of the sample size. So square root of 100 is 10. The standard deviation of the sample mean is 1.5. So what does the distribution look like? Well, the central limit theorem states that for a large sample, distribution is approximately normal. So, right, normal distribution. C, find the probability that the sample mean age is more than 30 years. Okay, more than 30 years. So greater than 30. So the probability is greater than 30. So 30 would be our low number, and then we'll use e to the 99 as our upper limit. We put this in our calculator. We get 0.9962, or the probability that a sample mean is more than 30 years is 99.62%. Then last, D says find the 95th percentile for the sample mean age to 1 decimal place. So we will pay attention to what it's asking. And the 95th percentile for percents, we will use inverse norm. Since we already calculated this, we could just put in 1.5. I just want you to know where that comes from, so I'm writing it out. But you could just put 1.5 since we already calculated it up here. So inverse norm 0.95, 34, 15 divided by the square root of 100. We get 36 points at one decimal place, so 36.5 years. So the 95th percentile for the sample mean is 36.5 years.